In this video, we will learn about special exponential functions. Mainly, we have to deal with investing problems. What will happen to your money if you invest it for a certain amount and the principal amount is given? You can see here it's about compound interest. Ryan invested $5,000 in an account that grows continuously at an annual rate of 2.5%. Write the function that represents the situation where A is the value of Ryan's investment after T years. This is important to note that it's continuously compounded. That's very important. That means it's a E is related, exponential function is common. Now, this is Euler's number. For all problems where continuous is there, the formula is A equals P ERT. Let me write it out again. Please remember this. A is the amount of money after certain time. P is the principal amount where you invest certain amount. See, invested. This is principal amount P. E is Euler's number. R is the rate of interest. That's always in percentage. T is the time. That's it. Now, this is a writing question. So let us write the given first. Given would be P equals it's not 2,500, it's $5,000, 5,000. Next over here, R is 2.5%. What is 2.5%? This is 0.025. You just divide this by 100, or you can put this percent in the calculator as it is. Let me show you how you can solve this in calculator. All you do is press the number, whatever is given, in percent. Now you can use the percent symbol over here, that is by shift, and the symbol here, it's percent. Now press equal to and press SD, you get it in decimal form. It's 0.025. Now those are the only two things that's given. And the first problem in this, condition A, write the function that represents the situation where A is the value of Ryan's investment after T years. Now A, we don't know. After T years, that means let us keep that as T, but substitute all the other things. 5,000 e to the power R is 0.025 T. So this is the equation we can form. That's it. That's the answer for the first A part. Now these are two full problems, like A and B will be there. So that's it. And let's see what's the second part. What will Ryan's investment be worth after 7 years? Now we use the same formula. Now if you're writing in other space altogether, if it's under B, what I would suggest you to write is given year again in the second. This is A. Now for the B, given is, this is already done, right? So let's just write T is equal to 7 years. We know that A equals 5,000 e to the power 0.025 t. Now A will be equal to 5,000 e to the power 0.025 times 7. All you need to do is use the calculator and solve this up. It'll be 5,000 multiplied by. Don't use alpha and e because then you'll have to use other options over here like power. You can simply use shift and ln, that's natural logarithm, you get e value. Then if you type in it's 0.025, or you can even write 0. It's the same thing, multiplied by 7. That's it. The answer is 5956.23. So the amount initially invested was $5,000, but after 7 years at the annual rate of 2.5, which is compounded continuously, you will receive 5,956.23. Now here they did not mention round off to certain digits or anything. If they have not mentioned, just write 2 digits, that's enough. So it'll be amount is in dollars. So this will be after 7 years. Remember, if they don't mention round the answer to nearest 10th or nearest 100th, then just do 2 decimal points. This is nearest 100th. 2 decimal points after the 2 digits after the decimal point. This is how we solve this problem. Very easy, isn't it? Now that's it in writing. Let me solve the others as well. It's again the same thing. What's happening here? Investment is P. Here the rate is R. And we have to write in terms of T. So the formula, we need to write given P is equal to 6,500 it's dollars, and we have R that is equal to 3.25%. That is equal to 0.035. You can use your calculator to check it out. Now next what I would do is write the formula solving A equals, see they want where A is the value of amount after a certain time t. A equals PERT. This formula must be known by you. A will be equal to P is 6,500 multiplied with ER is 0.035 t. I know you might be thinking, can we directly write 3.25? Okay, I've written wrong over here. It's 3.25. So it's this error. Please don't do the same mistake which I did just now here in your exams. Look at the numbers. It'll be 0. This moves 2 times to the left side. It'll be 0.0325. And over here also 0.0325. Okay. T. Now here, remember, this is it. But if you're writing directly 3.25%, it is correct, but it's not desirable. Please try to expand it. You can get this answer from the calculator. We just did it. And write the expanded form. And that's it. That will be the answer. And now let's see the B answer, the B question. Okay, this is the second part. What will it be after 18 years? This is A. Now B over here is given. T is equal to 18 years. Then what we have, the same thing, A is equal to 6,500 e to the power 0.0325 multiplied by t is 18. Just substitute the t value. I would highly suggest you to write the formula, this thing first, and then substitute it, because in the B, otherwise it's just one sentence, that's it. You can write this formula which you obtained from A, write it, or you can write we know that, something like that, and then substitute t as 18, and now just put it in the calculator. I did not remove this because I'm just gonna edit it over here. It's gonna be 6,500 or 6,500, 0.0325, and the t value is 18 years. So the answer would be 11,667.44. So the A value is 11,667.44. So that is the answer. And this was the part A answer. Similarly, I would highly suggest you to do the next problem by yourself, and then I would do it. You can pause the video right now and do this by yourself and then watch the video. Here again we got P, R, and they want A and T. So the given is P equals $12,750 and R is equal to 5.5%. This is equal to 0.055 because this moves to the left side, or you just put this in the calculator. 5.5% is 0.055. Now what do we need to solve? It's the formula PERT. This whole thing is equal to A. Now substitute the given. A is 12,750 multiplied with e to the power R is 0.055. It should be written properly, but anyways, I just edited out there. T. This is it. That is the part A. Now in the part B, they will be giving you time, and then we solve what's the amount of money after certain time. So that's the first part done. Now what's it after 9 years? So we are given t is equal to 9. It's desirable to write this first, as it is the formula is 0.055t. Now do the substitution. A is 12,750 e to the power 0.055 multiplied by 9. The amount will be finally after 9 years when we put it in the calculator. So here it is 12,750. So 12750, and over here we have 0.055, and the time is 9. There you go, it's 20,916. So the amount of money, dollars, is 20,916.35. So that's the final answer, guys. So that's it. Very easy problem, isn't it? Also, you can write the statement, after 9 years, who is this person we are talking about? It's Masala. Masala's investment will be worth 20,916.35. Even if you don't write this, it's fine. Just write given T. Whatever I've written is more than enough. For the first A, given, substitute formula and substitution done. For the second part as well, given, write the time T in this formula, substitute, put in the calculator, write the answer. Very simple problems. And that is the end of question 1, a very easy topic. In this question, we will look into the exponential growth and decay functions. These are all real-world problems. Here we have about population. In 2000, the world population was estimated to be 6.124 billion people. In 2005, it was 6.515 billion. Write an exponential growth equation to represent the population y in billion t years after 2000. Now, what basically they want is the population growth. As you can see here, it was 6.124 in 2000, and it grew, or it was increased to 6.515 billion in 2005. And all the time we consider must be after 2000. So how many years after 2000 is 2005? You just have to count 1, 2, 3, 4, 5 years. So t will be 5 years, just like that. But now over here in the first situation, we just have to write t years, that's it. And over here y. But what is the formula? It is y is equal to ae power kt. Now here this is positive k. Why? Because this is growth function. If it was decay, there will be minus if it's reducing. So let's start solving it. Let's see the given. Always remember, this A is the initial population. If you have 2005 and 2000 populations, right, this and this, the A value will be the smaller one, in the sense the earlier one, that is 2000 will be A. So given A is equal to 6.124 billion people. Let's write in terms of billion itself. So that's it. And then what is the time? Because see, now we have to write the equation. To write the equation, what is very important? K value is not given. That is what we need to find. So now if we substitute everything, then we can find K value, isn't it? So let's try that. Now this is A. What is the time from 2000 to 2005? Time is 5 years. So this is years. And then what do we know? What is the final population? Y is after a certain time. If t is 5, after 5 years, the population y will be 6.515 billion people. So now we know almost everything. And E is Euler's number. That's a constant, 2.71. Now what we do is we'll just substitute. This is 6.515. Now this is a B. B is billion. Don't write this, okay? I'll just cut it off over here. Not 8, it's B. Equals, what is A? That is 6.124. E is Euler's number, and K is the value we are going to solve for. And time multiplied by time is 5. Now how can we solve this? Now you can put this entirely in the calculator and get the answer, but let's do a simple step because it's in the writing part. I will take these numbers to one side and simplify as much as possible. So 6.515 at one side divided by 6.124. This will be equal to e to the power k multiplied by 5. Now you can take natural logarithm on both the sides. You can write another step. ln will be 6.515 divided by 6.124. That will be over here at the right side, ln e to the power, I write 5k. Now what happens here, whenever you have logarithm, this whatever is there comes down, right? The property of logarithm, the powers will be the coefficients. So then ln and e is 1, so they cancel off the inverse, so it will be 1. Then you can just put in the calculator and solve it up very easily. So then after this, it's very straightforward. So what you can do is write so much, and then let's put it directly in the calculator and we'll get the answer. I'll show you now. All we have to do is see ln, that's natural logarithm, divided by 6.515 divided by 6.124, close the bracket, equals is alpha and equal to ln. E is given as over here shift and e to the power phi alpha x, and close the bracket over here. That's it. Now you can just press, because we have the variable and equation, you can't press equal to. This is an error, it will give you a syntax error. You need to press shift and solve. This is not the answer, this is whatever was stored before. This is not the answer. You need to press shift, solve, and then equal to, and this is the correct answer, 0.1237. So now many of my students used to ask me how many digits to write here, 4 or 5. In the textbook, sometimes they are taken 5 digits, sometimes 4. So what I would suggest is minimum number of digits to be taken is 1,000, 4, sorry, not 1,000, 10,000s. 4, 1, 0, it's sorry, 0, 1, 2. You can now round it off from 3, 7 to 4. Okay. Now in your solution sets, they might have taken 5. It's fine. Now sometimes you can write 0.1238. So if your answer is varying in a range, that is absolutely fine as long as you have done it correctly. Now technically minimum digits to be taken is 4. You can take even 5 or 6. Don't go more than 6. No one takes more than 6. So this is the k value. Now I'll just show you, even if you put this equation entirely in the calculator, you'll get the answer. Now one thing, it will take time for your calculator to solve. It might take up to 20 seconds. So once you press shift and solve and equal to, wait for it. So let me show you over here. E is shift and ln, and over here alpha x multiplied by phi, and you just have to press shift and solve equal to. See, now this calculator is a computer simulation, so it gives it very quickly. The answers are shown very quickly. But when you have your physical calculator with you, it takes time. So please be patient. Don't press on or AC. It'll have to be redone there. So this is the same answer any way you do. That's the answer. But now look here. We just found the k value. For the part A, they have asked you the exponential equation. That's this growth equation. Now once you find the k value, you should write y is equal to, what is the initial A? Population is 6.124. E to the power k is 0.0124 times t time. This is the equation, what they want in the part A. The k value was not known, so we did the formula, we substituted all the given and found the k, and then we got this. So that's the part A1. And you can see over here, that's the answer. Now we can leave that. Let's go to the part B. Now see over here, you might be thinking it's too much. It's fine. Whatever I've written over here is more than sufficient. This is all the important steps that are required. Then over here you can write this. So the population, whatever the question, again you can rewrite and tell this is the answer and all that stuff. So what I would suggest is write the given, write the formula properly and simplify it, and then leave some space. Again, you can write the formula and do the substitution of the equation. Now let's go to the second part. Use the equation to predict the year in which the world population will reach 7.5 billion. In fact, I need this because that's the equation, right? I'll keep it over here and I'll do the part B somewhere over here. This is all A, this is B. So the given will be the same for both, but just that over here now, this is done. This was only for the first part. Now the Y is given as 7.5 billion people. So they want to know when will it reach 7.5 billion people. All you do is use this, but instead of Y, I'll put 7.5 equals 6.124 e to the power 0.0124 times t. Now again, what do? Don't directly put this in calculator. Yes, you will get the answer, but just try to simplify a couple of steps. Let's take this to the other side. It'll be 7.5 divided by 6.124 equals e to the power 0.0124 times t. Don't take natural logarithm over here in the first step itself because there are two terms here. You have to use properties and stuff. So simplify the numbers. Now you can see this is a single term when you solve it, right? So now you can take ln on both the sides. It'll be 7.5 divided by 6.124. That is equal to ln e to the power 0.0124 t. That's it. Now use your calculator to solve for t. Let me show the substitution here. Use the fraction, ln fraction. It's 7.5 divided by 6.124. And let's close the brackets. Equals, it is ln again, natural logarithm, e to the power that shift ln 0. It's 0.0124 to the alpha x. The t is written as the variable x. You cannot put t or y. You have to use this variable x only. Don't use the other variables, because when you shift and solve, it doesn't give you the answer. Only x can be solved in the calculator. And that's shift and solve. This is the previous answer which is stored. Now when you press equal to, here you go, it's 16.34. That's the answer. Let's just double check. Yes. Now see here. Here the answer is 16.372 and here we got 16.34. That doesn't matter, because see here, they have taken 0.01238. Now we have rounded off to 4 decimals. So it's absolutely fine. Now I'll just show you over here. If I take it as 38, I'll just change this to 38 and shift and solve, then press equal to, your answer is exactly what the textbook is having. So don't worry, as long as you have done this correctly and you've got something related to 16 point, that's more than enough and you will definitely get the full marks. Okay, I'll just stick to what I have written over here. That is shift and solve and then equal to, so the time it will take is, t will be 16.35 years, rounding off to 2 decimals. See, another thing is the error is we take 2 decimals at one place, 3 decimals or 4 decimals. It depends. I mean, this is not 3 decimal over here, 4 decimals, 3. So that's why there might be a minute error, but that's absolutely fine. You are technically supposed to get full marks for that. No problem about it. So that's the answer, guys. And so after 16.3, nearly after 16.37 years, from 2000, the population will reach 7.5 billion. So when does that happen? So it'll be in the year, which year? If you add 16 here, it'll be in the year after 2016. So that's it. So that's how we solve it. Let's solve this one as well. Jason wants to buy a new HD television, but he thinks that if he waits, the quality of the HD television will improve. The television he wants to buy costs $2,500 now, at present. That's now. It costs so much at the present. And based on pricing trends, Jason thinks that the price will increase 4% each year. So certain products will always keep on increasing its price after each year, right? Because of inflation and other stuff. So this increases every year by 4%. But the HD quality will improve as well. Write an exponential growth equation to represent price y of a new HD television t years from now. See, now we have to write exponential growth equation. Y is equal to e to the power ae to the power kt. I just got confused for a minute. Now here let's write the given. So we know the initial price A is $2,500. We have this 4% here. That's the K value. Remember, we had another formula. A is equal to PERT in the question 1, right? So this R is the rate. Rate is always percent. Same formula here. Instead of A, we have Y. Instead of this Y, we have A, this capital A. Now P is replaced by A and E to the power KT instead of RT. RT and KT, right? So K is the rate, percent. So K is given as 4%, that is 0.04. That's it. Now, no other values are given. Let's substitute what we know and write the equation. Y equals 2,500 e to the power 0.04 t. That's it. That is it. That's the part A, because they have given you the K value and A value. It's so easy. That's why. Let's say that's the equation. Let's look into the next part. Use the equation to predict when a new HD television will cost 3,000 dirhams. So when will it cost? The final cost after a certain time is always Y. It's $3,000. So when will this be 3,000? Y is equal to 3,000 equals 2500 e to the power 0.04t. All you need to do is find the t value. You can put this directly in the calculator and get, but let's do some steps. I'll take this to the other side. It'll be 3000 divided by 2500. That is equal to e to the power 0.04t. And now take ln on both the sides. So we will be 3000 divided by 2500. That will be equal to natural logarithm over here as well, 0.04t. And now we can just put this in the calculator and directly we can get the answer of t. That will be the time it will take for this television. Every year, if it increases at the rate of 4%, it will, after how many years it will reach 3000 basically. I have already substituted because we have substituted the same thing in the previous question, first question as well. So here we have 3000, 2500, ln 0.04 and t is alpha x. So alpha over here, this is the symbol, and x is over here. When you press that, you'll get the variable x. Shift and solve and then press equal to, what's the answer? It's 4.5580. Now for time, I'll just take 2 decimal points, right? 4.56 years. So after 4.5 years or nearly 4.6 years, this initial cost of 2500 will inflate to 4.56 years. So that's the answer. And you can write sentences, but as long as you have solved this properly and you have highlighted this answer, that's more than enough. It's 4.6 years away from now. They have not asked you to round out it, like in the sense rounding off is not mentioned, so you can write 2 or 3, whatever. But imagine they had told you round off to the nearest tenth, then only 1 digit after decimal point, and so on. Okay, it depends on the question. Let's move to the next. Okay, there is C part as well. Let's look into this. Jason decides to wait to buy a new television and saves his money. It puts $2,200 in a savings account with 4.7% annual interest compounded continuously. Determine when the amount in his savings will exceed the cost of the new television. Okay, this is interesting. What they are saying is, now he knows this television will initially cost 2,500 and it's increasing 4% every year. Now what he does is he saves in the bank $2,200, but that will compound every year 4.7%. So the same thing, what we did just a while ago, see this equation which we have written, right? See this one. Now we have to write again for this one. When will this equation be greater than this equation? In the sense, when will y money, okay, money which he puts is greater than y cost, of TV, cost of TV. So this is the thing, money saving, okay, save. Let's write the equation over here. We know this equation was y will be A is the initial cost 2,500, e to the power 4% is 0.04 t. When will this be greater than, say 2,200 is the initial amount which is depositing, e to the power, what is 4.7? It'll be 0.047. You can put in the calculator directly and get the answer. So in the topic 1, we have already solved the such things and multiplied by t. So you can solve it directly in the calculator, just this inequality make it as equal to. But before that, let's simplify how much we can. So I'll take this 2,200 to the other side. You're remaining with E 0.047t greater than 2,500 divided by 2,200 e to the power 0.04t. Here you can put this in the calculator and get the answer, but let's just do 1 or 2 steps, because steps are important because it's writing exam, isn't it? We can take ln on both the sides, natural logarithm. It'll be e to the power 0.047t. This will be greater than ln over here. It'll be 2,500 divided by 2,200 e to the power 0.04t. Now when what happens is basically ln becomes, because of the properties of natural logarithm, when you have 2 terms a and b, see, ln a multiplied by b will be equal to ln a plus ln b. So here we have this 2,200 This is one term plus ln e to the power 0.04 t. Now you can easily solve this up. Get t to one side and solve it up. Over here, this and this cancels, and you're remaining with basically only the above term, 0.047t. This is again another property of natural logarithm. Y e to the power x is equal to x. Whatever is up just comes down, that's it. So now we have this term, right? We have done so many steps, that's more than enough. I'll directly put this in the calculator and I'll show you the answer now. Here I've just substituted this equation, 0.047 alpha x instead of t. T is the variable. Now here inequality is considered to be equal to ln 2500 divided by 2200 plus ln e to the power 0.04 t. So you just press shift and solve. This is the previously stored answer. When you press equal to, you'll get this correct answer, current answer, sorry. What I mean is it's t equals 18.26 years. So this is the amount of time you will have to wait if this money deposited will match whatever the cost of TV is. That's like forever is never going to buy the TV, you know. So practically no one's going to wait so much, but you know, if we put so much money and for all this situation, this will be the time. So that'll be the answer over here. See the inequality, just write at least a few steps. What we have written is more than enough. If you want, you can even continue more answers. And now round it. It's not mentioned to round off this answer to nearest 10th or 100th or 1000. So I've taken 2 decimal points, that's fine. Or you can do a single decimal point, it's years, you know, it's time. It'll take 18.3 years. So now we have half-life problems. Now these problems are decay problems. So here y equals a e to the power kt, the same formula, but you will have minus because it's decaying, it's reducing the amount. So this is very important. Now here what is given, you need to write given for every problem. I may not have written for all problems, but please do try to write it. Now given a radioactive substance has half-life of 32 years. So what is the time? It's 32. Now what is exactly half-life? Half-life is the amount of time taken for a particular element to come to its half of its initial amount. In the sense, if there is 100 grams of, you know, some substance which is radioactive. Now if 32 years is half-life, after 32 years, it will come to 50 grams. Then again after 32 years, it will come to 25 grams. Then after 32, it'll come to 12.5 and so on, and there'll always be small minute trace of that element. So that's about half-life. Here it's always in 32, it becomes half. So that's the time t. Now there is a very important thing. Whenever they mention half-life, there is a rule which you must remember. Y is always equal to half of a. Why? Because when you put this t as the half-life, t is 32 years. After 32 years of time, this y will be half of 50. If initial amount was 100, y will be 50, right? So directly we can take half a as y, that is equal to a e to the power minus, we don't have the k value, we have to find the k value, minus k, but we know the t value is 32. This is it. Now a and a cancels off over here, so you're remaining with half equals e to the power minus k times 32. Now take ln on both the sides. This is ln half, that is equal to ln e to the power minus k times 32. Now you can just use your calculator and solve it directly. I've substituted this equation, ln half equals natural logarithm e to the power minus, that k value is unknown. Now we are solving for that, so that's x variable. This is multiplication symbol 32, and we can't press equal to, it will be syntax error. Let's press shift and solve. This is the last answer which is saved, and the answer over here is 0.02166. So what I'll write over here is k value is equal to 0.02166 will be 7. I remember long back one of the student asking me, this is minus k, so is this minus answer? No, when we solve it in the calculator, the minus sign is already accounted for. Whatever x value we get is, whatever answer we get is, that's it. If over here we have minus, then you have to put minus. Otherwise, that's it. So this is the k value. Now we will write the given equation. Y equals a e to the power minus 0.0217 t. So this is it. Now you can see that's the answer. Now here we don't substitute anything to a because it depends on the condition or the amount of a substance remaining or what was used. So that's the answer. Now second one, how much of 5 grams sample of radioactive substance should be left after 100 years? Now this is again very important. See, 5 gram sample, how much of 5 gram sample of a radioactive substance should be left after 100 years. So now initially you have 5 grams, that is a value, you have 5 grams with you. After 100 years, t of 100 years, this is b, this is a. If you spend a time of 100 years, how much will remain? Now we will use the same formula, y equals a e to the power minus kt. But now we have solved this situation, right? And we have got that. We should use this actually instead of k. But anyways, I'll write it again. Y is equal to, what is the y value? If a 5 gram sample, that is a is 5, e to the power minus 0.0217. And after how many years? T is how much? 100. This is it. So you have to just put this entirely in the calculator because there's nothing else to do. Here, remember, there is no variable like x is on other side of inequality or equal to, sorry. So you just put this entirely right side thing in the calculator without any variables. So it's minus 0.0, so it's decimal 0217 multiplied by 100. So here we get 0.57. So that is what remains. If you have a 5 gram sample right now after 100 years for this particular condition, only 0.57 grams will remain. So that will be the answer. See, 0.57. Another carbon dating problem, again the same thing, half-life is there. This is always decay, and they have also mentioned the way it's decay constant. Carbon-14 has a decay constant of k is equal to 0.00012. Use this information to determine the age of the objects based on the amount of carbon-14. So now here k value is given. See in the formula y is equal to a e to the power minus kt, right, for decay. K value is already given. We need to see the condition and then solve how much time we have to tell. Determine the age. Age is the time. T we have to solve for. A fossil that has lost 95% of its carbon. Okay, this is very important, carbon-14. 95% is lost, gone. So how much is remaining? Only 5%, right? So what is this? 95% of the initial amount is gone. So imagine it was 100 grams initially. A is equal to 100. So what happened is 95% is gone. So 95% grams gone. So what's remaining? Y is basically 5 grams. That's it. Or you can always write such things as 5% of A, of the initial amount, right? 5% multiplied by A is 100 grams. You will have 5 grams. So this is the trick over here. Always remember, you should know how much is remaining, not the lost, how much is there. So if 95 is lost, only 5% is there. So 5%, that is 0.05. Okay, 5% is always 0.05. 0.05 times 100. That'll be 5. Now here 0.05 A, because that's 0.05 times the initial amount is equal to AE minus, what is the K value? It's already given 0.00012. When it's mentioned, don't go to round it off. Take the entire value, whichever is given to you, times T. A is gone. So you have 0.05 equals e to the power minus 0.00012 times T. And then you can just put this in the calculator directly and get the answer, or you can take ln on both the sides and still you'll get the same answer, e to the power minus 0.00012 times T. So I'll show you how we can substitute in the calculator. I've just substituted over here. Natural logarithm 0.5 equals ln e to the power minus 0.00012 alpha x. You can write multiply and then write x, or directly write x. It's fine. It'll be multiplied itself. Shift and solve, not this. Press equal to, you will get the answer. It'll be 5,776 years. So the time taken is, okay, now there is some error which I did over here. I will keep that error because it's a very important error. See, look here. I have taken 0.5 in the question. See, one simple decimal point made the entire question go wrong. The answer is 24,964, which is the correct answer. But over here, I wrote everything properly, but just over here, I forgot to write the 0. So I thought I'll edit that part, but no, I'm just leaving that part, the error part. The reason being, because of that one single 0, my entire thing was wrong. So don't do that mistake in the exam. So for the 95% of the carbon to be gone, to be lost, it'll take 24,964 years. That's how we solve it. And there's a B part as well. The same question, but they're asking an animal skeleton has 95%. See, this is has, it's not lost. See, this is a very important distinction. 95% is a remaining, it is remaining. So here y is 95% A or 0.95 A. So out of 100, if initially A was 100 grams, 95% remaining means 95 grams is still there. That's what it is. So here it's the same formula. Let me just take it off. You have to write given and everything for each question. Now the formula is given as y equals AE minus KT. Why? Because minus is for decay. Now all you do is substitute this 0.95 A equals AE to the power minus 0.00012 T. And now here this A and A cancels off because both are initial amounts. And here you have 0.95 equals e to the power minus 0.00012 t, and take natural logarithm on both the sides and just put it in the calc ln over here, minus 0.00012 t. And now we will substitute in the calculator and solve it up. So here I've just changed that 0.095 and then everything was same. And we'll press shift and solve and then equal to, here it just takes 427 years. You can see here time is 427.44. In the exam you can write at least 1 or 2 decimal points. They have not mentioned anything about the decimals, so just write 427.44. don't write many decimals, just 2 is enough. Maximum 2 or 1 is enough. Even if you write whole number, it's okay. So that's how we solve these problems. And this is the last problem in this. It's about half-life again. Half-life is decay, so it's y equals AE power minus KT. Let's look into the problem now. Archaeologists uncover an ancient wooden tool. They analyze the tool and find that it has 22% as much carbon compared to the likely amount that it contained when it was made. Now what this means is 22% of the carbon amount is remaining. It has it. So initially if A was 100 grams, now Y is 22% of 100, that is 22 grams. So this is Y. Okay, so that is the thing. So now in this case, you need to write given, but I'll directly substitute over here. Y will be 22% is 0.22 A equals AE to the power minus, what is the K value? Carbon is always having 0.00012 and time is what they require, isn't it? So when it was made, given that the decay constant of carbon-14 is 0.00012, about how old is the artifact? Now we just solve this up. A cancels, seem like what we did a while ago. 0.22 equals e to the power minus 0.00012 t. Let's take ln on both the sides. And that will be equal to ln over here as well, e to the power minus 0.00012 t. And now what we do is we use the calculator, directly find t. You can see here it's ln 0.22, ln the negative 0.00012 alpha x is for the time. Just shift and solve and then equal to, your answer will be 12,617 or nearly 18 years. So it's 12,618. It's rounded off to the whole number itself. That is the answer. So simple as that. You do not need to do all the entire steps. Whatever I've shown over here, that is more than enough. And then directly write the t to 12,000 and so on, right? That is enough. So that's it. And if you want, you can even write the same thing, last part of the question. The artifact is, or the wooden tool is about, the answer, whatever you get, so many years old. So that is the end of question 2. Please make sure you remember the formulas, write the given, substitute, and then do a couple of steps, and then finally put it in the calculator and then solve for the answer. Before we move on to the next question, a humble request to all of you. If you're finding these videos helpful, please do share it with your friends. Let them know about this channel. There are more than 1,000 videos related to math. Another humble request to all of you, please do subscribe to my channel. I want to thank all those who have subscribed to it. As you can see, only 22.3% of my viewers are subscribed to the channel. It would mean a lot to me if you could just hit the subscribe button. In this video, we will learn how to graph rational functions with oblique asymptote. Before we begin, I'll just tell you when the oblique asymptote or the slant asymptote exists. Whenever you have the numerator of degree more than, obviously it should be more than 1. Over here, what's the degree? It's 2, right? And the denominator is having only degree 1. When the difference in the degree is just 1, see, 2 minus 1 is 1, right? Then there will be a slant or oblique asymptote. There will not be any horizontal asymptote, and every rational function will have a vertical asymptote. So this is the condition. Now, when you're solving such problem, you have to expand this because we have to do the long division method for oblique asymptote, right? You have to expand this. Now, it is a minus b the whole squared form, right? A squared minus 2 times ab plus b squared. We have to use the difference of whole squares formula. And let's substitute here x minus 4. Instead of a, we have x squared minus 2 times a is x, b is 4 plus 4 squared. It will be x squared minus 8x plus 16. So this is the expansion. So this is equal to x squared minus 8x plus 16, that is divided by x plus 2. So this is just the expansion of the numerator, and we write it out. Now I will start with the proper steps. The step 1 is about zeros. All we do is whatever is in the numerator that's up above, we make it equal to 0. Now I'm not going to write this because this is more easier to solve. X minus 4 the whole square equals 0, right? What happens, you can just take the square root on both the sides. It will be x minus 4 equals 0 because square root of 0 is 0. And then we have x is equal to positive 4. So that's the answer. Even if you solve this right side, that is the quadratic term, you'll get the same thing. I'll show you now. We can use a calculator to solve this. Here we need to click mode, phi, and quadratic, right? It's option number 3, mode phi 3. See the coefficient of x squared, that is a, then x coefficient is minus 8, and 16 is the last constant term. So it is 1, minus 8, and 16. So the answers are 4. Only 4. See, you can see it's only x. Otherwise, you will have x1, x2, isn't it? So that means the reason for that is because it's the repeated root. 4 is twice. That's the thing. Now, what about the second step? Step 2 is basically vertical asymptote. Vertical asymptote. Now, how do we find this? Is very simple. Over here, for the first zeros, numerator was equal to 0. This over here, denominator will be equal to 0, whatever is down. So that is equal to minus 2. That's it. So we have a vertical asymptote at negative 2. And then what do we have is step 3, the very important one, oblique asymptote. Now, since over here degree is just by 1, I'll directly go with oblique asymptote. OBLIQUE asymptote. Okay, and it goes on. So then how do we do this is, we do the long division. Now you can't use this whole square term, you have to expand it, and whatever is up, we write first. Now, before we start solving this, imagine you have a fraction, say 20 divided by, say I'll take 4. How would you, now 200 divided by 4, that would make much sense. How would you solve this? By long division, if you're doing, the above term will always be written inside this, two lines. And whatever is the divisor, that's what we are dividing by, is outside. Now we group them. We can't take all of these numbers. So let's see. 20 divided by 4 is by 5 times. So over here we do it 20 and then we solve it up. And since it comes 0, we take 0 and so on. It's 50. Similarly, for long division, we use the same concept, but it's just that we have variables over here, So now you can see this. X squared minus 8x plus 16. And over here, this is x plus 2. Whatever is up over here, we write it over here and denominator as x plus 2 outside. Now, how do we solve this? Is very simple. You need to focus on this first one and this one. Now, whatever is inside is up above, x squared divided by the outside. Only this, not the 2. Now solve this up. Whatever it is, the first term of the numerator divided by the first term of the denominator. That is x. So you need to apparently multiply x to get x squared, isn't it? So that's it. Now we multiply this term with over here x, so we get x squared. Then it's not over because there's another term, this multiplied over here with x, that will be plus 2 times x. Then when we change the sign to minus, this cancels off, and over here minus and minus will be minus itself. Oh, now very important, this is an important thing, changing the sign. You need to change the sign to negative over here, okay? That's very important, and over here also. If this was minus, this would have been plus, but since it's plus, we change it to minus. Now add them up. Minus 8 minus 2x will be minus 10x. Now you do not need to complete. See, the long division would be by bringing this term down and solving it up. But I will tell you a shorter method because our goal is not to do long division. Our goal is to just find the oblique asymptote. You do not need to bring this down. All you need is in the other constant term. What is the next term? You don't need this term at all. So here what you do is basically, I'll just change the color. Again, look into this term and look over here. What is this term? It's negative 10x. So negative 10x divided by the denominator's first term, x. That will be x cancels. It's minus 10, isn't it? So now over here what you write is minus 10. You can just stop here. You don't need to continue further. You can continue further. This will be multiplied. It will be minus 10x. Then over here, this would be down. 2 times 10 is minus 20 and solve it up. But you do not need for your exam, okay? But what I'll do is I'll just write it in blue, the continuation. This is what you need to do at least for your exam. This much is compulsory. But here, you can bring the 16 down. It will be plus 16. And now you can multiply x times minus, it'll be minus 10x, and then 2 times minus 20 over here, and then this cancels off when you change the sign changes, it'll be 36. So this is the remainder. But whatever I have done in blue, you do not need to write in the exam. Only so much is enough because all you want is this particular value. When you get to the constant term, you stop. That's it. So the oblique asymptote is given as y equals x minus 10. So this is a very important thing. The step 1, step 2 are pretty simple. Step 3 is about oblique asymptote. Now step 4, all you need to do is make the table of values. So here these are important values. I will just clear it off, and what I'll do is I'll just write, remember the zeros, vertical asymptote and the oblique asymptote. Now let's continue. These are the 3 steps values, but you have to do in detail, which I just did. Now I've just highlighted it over here. Let's continue with the step 4. Now what is the step 4? It's table of values. Table LE of values. Now this can be easily obtained in the calculator. You just need x and y values, nothing else. Okay, you should make a table. Generally in the exam, you might be given this table and you might be given the graphing coordinate as well. So we need a calculator for this. Now here you can use the expanded form or this form, doesn't matter. I would just directly put the given question. It's mode and 7 for table. And okay, once you get the table option, it'll be f of x. Just type this out. It'll be x, that is alpha x minus 4, the whole squared, divided by alpha x, sorry, it's not y, I'm sorry, alpha x plus 2. That's it. This is squared the above term and denominator is x plus 2. You just press equal to. You may not get this. If you have the latest model of your calculator, you will get this option. Just ignore this. Just press equal to, nothing else. Many of you, from once you type the equation, directly jump over here to start. Now, where do you start? This is very important. In the table of values, you should know what is the vertical asymptote. What's that? It's minus 2, right? You have to take about 2 to 3 values before this. So I'll take minus 1, 0, sorry, my bad. It'll be minus 3, minus 4, minus 5, and greater than minus 2 is how much? Minus 1, 0, 1. I have to at least include these values. So starting point always varies depending on the vertical asymptote. Here it was minus 2, so 3 values less than minus 2 is minus 5. So I'll start at minus 5 and ending is at 1. So what is the step? You know, to get a more accurate graph, you can take the step of 0.5, but I'll just take 1 now for for ease. It'll be easier, the table. Now all you do is write the y values. Minus 5 is minus 27, minus 4 is negative 32, negative 49, and then you need to just see all the values. See, you get minus 2 error because obviously there is a vertical asymptote. At minus 2 you will not have any value. You can write over here vertical asymptote or just write error. That's fine because this already there. You can just write it over here. That is undefined. So better word would be undefined. UNDEFINED. If you're getting confused, just write error or vertical asymptote or anything. Okay, that's also fine. Now at 1 it is 25, 0 is 8, sorry, it's not 0, 8 and 3. So this is 8 and lastly we have 3. So these are the values. Now how do you graph? Now it is very hard to get the accurate graph. That is fine if it's not accurate, but as long as you've done the few important things, that's okay. So now let's see, 0 is 4. Where is 4? Imagine 1, 2, 3, 4, somewhere over here, right? Just plot that point. It's very important to know that point. Why? Because the graph touches. Now what about vertical asymptote? It's minus 2. So 1, 2 over here. Draw a dotted line. Don't draw a straight line. Asymptote is always denoted by dotted line. And what is the oblique asymptote? Y is equal to x minus 10. Now you don't need to graph it accurately by a table of values. Just see, this will always be a linear function in your problems. So minus 10 is somewhere over here, right? 1, 2, 3, 4, 5. It's somewhere over here. So you need to draw a straight line like this from minus 10. That will be your oblique asymptote. See, now this is the thing. I am sorry, I told you one thing wrong. Now, if you take a scale of 10, you can never graph it. Please don't scale. Sorry, if you take a scale of 1, like if you consider this to be 1, 2, 3, it's just not going to be possible, okay? So see, the values are around 27, 32, 49, 25 and everything, right? So what I'll do is I'll take this as minus 10, minus 20, minus 30, minus 40 and so on. And this I'll take it as 10, 20, 30 and so on. So now minus 10 means y value, that's the y-intercept is over here. So I have to draw a straight line somewhere over here. Now this will be a problem because if you draw it like that, it's wrong. Now x value 10 is somewhere over there, isn't it? It'll be something far away. But that's the reason, it's very hard to get a very accurate graph. So, but anyways, that's fine. Let's carry on. Now at minus 5, where is minus 5? It's somewhere over here. The answer is minus 27. So somewhere over here will be the point. Minus 4 is 32. Minus 4, it will be negative 32. Minus 3, it's negative 49. and -2 it's undefined, obviously, because this is the asymptote. So you can see the graph would be something like this. Okay, now this is not at all accurate, guys, but I hope you're getting the gist of it. Now what about other values? -1, it's 25 somewhere over here. At 0 it's 8, that's over here. 1 it is at 3, and then we don't have other values, that's fine. But you know, where is the 0? X is 4. At 4 it'll be y is 0. Something like this will be the graph. See, now this is not at all accurate. The line which I've drawn over here doesn't touch over there. Okay, the oblique asymptote goes far away, right, to 10. So that's somewhat the graph. See, now it's very, very not accurate. Let me show you the original graph and let's see. So that's the answers we got. And over here you can see this is the graph. Now the problem is, because of the scale, we had the issue. Now here what they have done is 4, 8, 12 and so on as the x scale, and this is minus 10, 20, 30. Now I should have done that because I've just taken 1, 2, 3, which is very inaccurate, because you can't, you know, compress the scale on the y-axis and leave the x-axis as it is. It'll be very, very wrong. So, but if you draw it properly, like approximate scale, it's fine. You will get the graph something like this. And at 4, you will be touching the x-axis. So this is the graph. Don't worry, you don't need to be very accurate, but very important things are these two lines. Again, I'll repeat, this vertical asymptote is where from x is equal to -2. And then this is the oblique asymptote. How you get it is by long division. We do that division, right? So from there. So that's how these two lines are very important. They need to be exactly accurate. These over here, if you get 1 point, you'll understand where exactly the rational graph is lying, over here and over here. So that's how we solve this. Now, similarly, we can do the other problems. Now, I won't go in detail or too much depth. I'll just solve them by steps. I'll try to solve all these problems. Now, step 1, I'm not going to write all the details, but refer to the first problem which I solved in detail. Write all the heading and everything. Now, here, just write x is -3. Step 1, that is the zeros. Step 2 is the vertical asymptote, and that is y is equal to 5. And over here, step 3, it is x squared plus 6x plus 9, that is the expansion of the x plus 3, the whole squared. And here we have x minus 5. So you have to multiply by x to get x squared, and then we will have minus 5x. This cancels off. Over here it'll be 11x, and then we just have to add by 11. So that's it. Now then the table of values table, that's step 4. I won't do the table because it's from the calculator. It's very, very straightforward, but I'll tell you what are the x values. Now, since you have, okay, vertical asymptote is always x, sorry, not y, it's x is equal to 5. And the oblique asymptote is y, that's x plus 11. Now here, since we have 5, somewhere 5 is in the middle, you can take 4, 3, 2, 1, and over here 6, 7, 8, 9. You can leave last two values. You know, don't take too many as well. This, if you take 3 values less and 3 values more, you will already have 7 values. That's plenty. Put this in the calculator, entire thing, you will get the y values, and then you basically graph it. In the graph, please give important attention to the vertical asymptote at 5, and then there is a 0 at -3, and then this is somewhere over here. It's something, oh, it's plus 5, so it'll be somewhere up above, and then you graph whatever you get it. I hope that's clear. So these are the answers. That's what we got. And here they have changed the scale entirely. That's fine. You can even do this. But even if you don't change the scale, x values, whatever you get, that's okay. You know, it'll be accurate enough. See, the graph, what we mainly look as teachers, you know, we will look into the way you have drawn the vertical asymptote. Where is the oblique asymptote? Is this two correct? And then some of the points at least, you know, the zeros, this is very accurate, this point. And then 1 or 2 points is enough, and then just try joining them. This rational curve, right, rational graphs curve, won't be accurate, but that's fine, you know. And now we will solve this one as well. Over here, what we do is, see, for zeros, step one is zeros, right? You need to use the calculator in this case. Why? Because it's a quadratic form. You have to go to mode 5 and 3 and then type the coefficients x6 plus 4 and 2. And then over here, this is imaginary. So what do you write in such cases is, there are no real zeros. There's no real zeros, only imaginary roots. That means the graphs will never touch the x-axis. That's step one. Step two would be vertical asymptotes. So here, vertical asymptote is x plus 2 equals 0, and you get x is equal to minus 2. Step three would be oblique asymptote, and we will just solve it out. Okay, let me just leave some space at the top because we have to write the answers, right? 6x squared plus 4x plus 2, and over here we have x plus 2. So it is 6x, and then what happens over here, it is 12 plus 12x. This cancels off minus, and you're remaining with minus 8x. And now we just see these two numbers, it'll be minus 8. That's it. So 6x minus 8 is the oblique asymptote. Now if you're thinking how to graph over here, obviously this will be minus 8 somewhere over here. That is the y-intercept. Now if the slope is more than 1, okay, as you get 6, it goes more and more steeper. Just draw it more up above, you know. So basically at 1, this will have 6y difference, you know. So at 1, it will be 6. It's not accurate enough. So for x value of 1, this must be 6, you know. So that is the concept. So that is the thing. But another thing, table of values, very important. Table of values over here, x and y. So what is the x value in the middle? It's minus 2. So take values such as minus 3, minus 4, minus 5. And over here, you can take it as minus 1, 0, and 1. So that's how we graph it. This is the step 4. And the fifth one is step 5, the graphing. Now this is inaccurate. The zeros are wrong. One more thing. When you have common terms, when you're solving that, it's much better if you do this. Take out the 2 common out. What is remaining is 3x squared plus 2x plus 1. And then you can solve this. But even if you solve this, here you will get a wrong answer. Why? Because this is, you will have imaginary roots. You can try it in the calculator. Now here the roots which they mentioned here, x is equal to 1 minus 1. Let's write the factors over here. X minus 1 means it'll be going inside. It'll be x plus 1 multiplied by, over here it'll be 3x minus 1. Let's multiply this. It'll be 3x squared minus x plus 3x minus 1. And now if you solve this up, you'll have 3x squared plus 2x minus 1. The error over here is this positive sign. I guess they meant to say this was minus, but then it wouldn't make sense. Over here we have already solved it, but that doesn't make much difference, you know, that line at that point, it plus or minus. So I think so that is the issue over here. They have not considered. It should be the minus, then you have real zeros. Otherwise you must write no real zeros. That is the thing. So over here, this is error. If you get imaginary number in your calculator, just write there are no real zeros. But most probably in your exam, you will have proper values. There won't be any error. This is supposed to be minus 2. You would get these two roots then. And here's the table of values and the graph. The graph is like this. Similarly, let's solve this one very quickly. The step 1 is zeros. So in the zeros part, what do we have? We have to put this in the calculator, or you can even try doing it by x. If you remove outside, you're remaining with 2x plus 7. So you have 1 0 of x is equal to 0 because this is outside. Another 0 is x is equal to minus 7 by 2. So there are 2 zeros. But what you can easily do is put mod phi 3, 2, 7, and there is nothing constant term, put it as 0. And then you can get the answers, mod phi 3. Now here, these are the 2 zeros, and then step 2 would be denominator. That is vertical asymptote. x minus 2 will be equal to 0, so x is equal to 2. Right over here, step 3 is oblique asymptote. What you need to do is do the long division. This is plus 7x, and over here x minus 2. So what do you multiply as 2x? It'll be 2x squared, and here it'll be minus 4x. Okay, now, yeah, this is fine, 2x. There is nothing, no other term, it'll be 0. So this cancels off, you'll have plus, it'll be 11x, and then you have to add 11. That's it. I'm not going to continue. I'm not going to complete the long division because all I need is the oblique asymptote. We are not doing long division over here. Y is equal to, we are doing it, but that is not our main goal. You know, our main goal is just the oblique asymptote. Just do y is equal to 2x plus 11. That is oblique. See, now this is zeros, oblique asymptote, vertical asymptote, oblique asymptote. Then you have to do the table of values. That's step 4. Now over here in the table, which is the mid value, it's 2. So take values less than 2, 1, 0, minus 1, and 3, 4, 5. These are the x values. You need to put this in the calculator to find the y values, starting from minus 1, end at 5. You can keep the step at 1 itself. And then all you do is make the graph, whatever the values you get, x and y. Make sure you plot the zeros over here and get the graph. See, let's look into that 0 and minus 7. Minus 7 by 2 is minus 3.5. You can see there is 0. Yes, it's touching the x-axis, and at negative 3.5 also it touches the x-axis. So that is the graph. Then over here as well. Now the 15th, that is the penultimate problem in this topic. Same thing, but here there is an important thing when you solve for the the oblique asymptote. When you do the long division, I'll directly jump over there. Don't write plus 8 directly. We must always have it in the standard form of ax squared plus bx plus c. Here you have 3x squared, but there is no x term. So it's 0x. Then we have 8. 8 is the constant term. And now here, there won't be any real zeros. Why? Because when you solve this up, step 1, let me just go over here, zeros, we do 3x squared plus 8 equals 0. You can just do modify 3, you will get I values, but otherwise if you do 3x squared equals minus 8, and then x squared is equal to minus 8 by 3, and what happens to x? Square root of negative 8 by 3. Is this possible? Square root of negative is not possible, so it's imaginary number. So there is no real zeros. There is no real zeros here. Whereas step 2 is very simple. The vertical asymptote is whatever is down. 2x minus 1, just make it equal to 0. 2x equals 1. X is half. That's it. Now what about this here, long division? 3x squared plus 0x plus 8. Now outside it's 2x minus 1. Now in this case, what we do is we will divide it. 3x squared by 2x. That'll be, this power goes off with this x, so it'll be x only. But what is this? 3 by 2 is 1.5. So the answer over here is 1.5x. So let's multiply 2 times 1.5 is 3 and x squared. And what about this negative times 1.5? It'll be minus 1.5x. So this cancels when we change the sign. This will be positive, and here it is just 1.5x. Now we don't need to do anything further. Don't bring this down or anything. Just whatever this number is, 1.5x divided by, what is this? It's 2x. So now what is 1.5 is half. Divided by 2 means half, right? This cancels off. You will have 0.75 basically. So 0.75 times 2 is 1.5. Here it's plus 0.75. So the oblique asymptote is y equals 1.5x plus 0.75. For the table of values, that's step 4. All you do is see what's the x value. That's the vertical asymptote. Now here you can do one thing. That's half, isn't it? You can take values like negative half or something, but what I would generally do is I'll take 0, minus 1, minus 2. What's the nearest whole number to this? More than half is 1, 2, 3. These are the x values. Then just put it in the table for y values. And in the graph, see, let's look at the graph. What is very important? This half, that's the vertical asymptote, is at half over here, and this oblique asymptote, is having the y-intercept at 0.75. Yes, that's correct. And it's 1.5, just a little more than 1. So it's like this. And then you can just plot the points. There are no real zeros. See, we had written over here no real zeros. Why? Because it doesn't touch the x-axis. And you can see here as well, there is no it's better to write no real zeros, which is much easier in understanding. That's it. And the last problem over here is the 16th one. Okay, this is the one. Same like the previous one. See, the previous one also we had the same situation, similar situation, no middle term, no x term, and over here also there is no x term. And over here, step 1 would be zeros. So whatever is up over here, 2x squared plus 5 will be equal to 0. What you can do it is, do it in the calculator mode phi 3. I'll show you again. Mode phi 3 and put in the coefficient 2. But there is no x term, so it's 0. And lastly, we have phi. So what's the answer? I. So from there, we can directly tell no real zeros. No real zero. Then step 2 is vertical asymptote. Here what we do is 3x plus 4 will be equal to 0. So 3x will be equal to minus 4, or x will be negative 4 by 3. So negative 4 by 3 is about 1.333. So it's 1.33 or 1/1/3. That's the step 2. Now step 3 will be oblique asymptote. Oblique asymptote will require long division. That is 2x squared. There is no x term, so it's 0x plus 5. And now you write it over here, 3x plus 4. Now let's start doing this. It'll be 2x squared divided by 3x, so it'll be 2/3 x, or you can write it as 0.666. So 0.67 is much easier to write. That's the rounded off number. But I will just write it as 2/3 x. That'll be 2. Now when you do multiply this 3 with 2/3, 3 cancels and you're remaining with 2, and x is x squared. This x is multiplied to it, it's in the numerator. And then what happens? This sign changes. And what about this? 4 times 2/3 will be 8/3. It'll be plus 8/3x. So this cancels off. Over here it'll be negative 8/3x. And now here it is 8/3 divided by 3. So 3 and 3 over here will be 8/9. That's the thing. And x cancels off. So it's just 8/9. What you need to do over here is minus is there. So you have to basically subtract it by 8/9. So when you multiply this over here, 3 over here, 3 cancels, it'll be minus 8/9, and then you can simplify it. So but that is not required. We just need this. So y is equal to 2/3 x minus 8/9. That is the oblique asymptote. And then the table of values, that's step 4. Here, table of values, all you need to do is, see, this is very crucial, x and y, right? What is the oblique asymptote? Sorry, vertical asymptote. It's negative 1/3, 4/3. So what is lesser than that? Minus 2, minus 3, minus 4. Over here, greater than that would be minus 1, 0, 1. So these are the values I would consider. I would find the y values in the mode 7 from the calculator and then graph it up. So you can see here, this is here what we got. That is the answer for the oblique asymptote, yes. And then these are the table of values. Now here it's very important to write this vertical asymptote is at negative 4/3 or negative 1.33. And this one, it's, this is almost equal to 1, but just little less than 1. It's something like 0.9. So you can see it's less than 1. That's the oblique asymptote. And then some of the values just plotted and pointed. And I mentioned there was no real zeros. Why? Because it was imagined number. So that you can see these graphs do not touch the x-axis. That is how we graph the rational functions with oblique asymptotes, and that's the end of this topic. The question 4 in the writing part is about normal distribution. We have different types of problem where we need to find relative frequency, probability distribution, the z value, and other things. We will solve each one of them. The first type of problem is just to identify random variable in each distribution. Now we need to classify whether this is discrete or continuous, and we need to explain our reasoning. Now the number of texts received per week. Now whenever a quantity given to you is countable as whole numbers like 1, 2, 3, 4, so on, and it's countable, it's discrete. You can count it out. Whereas it will be continuous if it's like 1.5, 1.35, and so on. It's like in decimals. So this is a simple understanding. Say heights of students in a class or weight of students in a class. It's not discrete, it's continuous. Whereas number of texts received per week, you can count it. You might have received 100 texts. It's countable, it's discrete. So this variable, the variable is what? Basically text received. The number of text received can be represented by a whole number. So the random variable is discrete. Now number of likes for a web page is also discrete, absolutely the same concept. The height of a plant after a specific amount of time, this is not discrete, it's continuous. The height of a plant is the variable, that's what's required, right? The height of the plant may be positive value, be any positive value. So this is very important, it can be anything. So it's a random variable that is continuous. And now we will move on to the relative frequency table. See, here they have given a real world problem. At a fundraising dinner, the underside of 200 plates were randomly tagged with a sticker to indicate the winning a cash prize. The frequency table shows the number of winning plates for each prize. Construct a relative frequency table and graph the probability distribution. Now they have given you all the different prizes, the frequencies. We need to see, they have told 200 frequencies totally, 200 plates that are winning cash prizes. So if there is, they have tagged whether you win $5, $50, $100, or $1,000. Only one plate out of 200 wins $1,000. There are 9 people with 9 plates that is winning $100 and 40 with 50, and the highest number of people are winning $5. These are among those who get this winning plate, So relative frequency is very simple. You need to first see whether the total frequency is given. If it's not given, just add them all up. 50 plus 40, 150 plus 40 is 190, 199 plus 1, 200. Relative frequency table, relative frequency is given by division of 150 by 200, 40 by 200, 9 by 200, 1 by 200. If they give you the exam, what I would suggest is do this table entirely. So it's price, that is X, frequency, type it out, write it out, sorry, 50, 100, 1000, that is $1,000. Now frequencies are given as 150, 40, 9, 1. You do not need to show this, but I mean in writing, but you can if you want. The relative frequency be 150 by 200, 40 by 200, 9 by 200, and lastly 1 by 200. So whatever the answer you get in the calculator, just put it over here. Write it in decimal, it's fine. So here it will be 3 by 4, it's 0.75. Here it will be 41 by 5, that is 0.2. Now here it will be very less, it's going to be 9. 9 is about 0.045, I guess. And this is going to be 0.0, like 1% is 0.01, but 0.005, I guess. Now you guys please use the calculator and get the exact values, but write in decimal, because this is an important table with relative frequency. But now what next? You need to graph it by probability distribution. The x-axis is here, $5, 50, 100, 1000. Now here you cannot go more than 1. See, it's 1 is maximum, 0 is over here. This is like 0.5, 0.6, 0.7, 0.8, 0.9. Same way you can write the other values here. Okay, it's not accurate, but you need to do it accurately with even spacings. Now, when it's 0.75, where is it at 5? 0.75 somewhere over here, you need to do a bar graph like that. And 0.2 is for 50, somewhere over here. This is 0.045, and lastly, very, very small. So that would be the answer. That would be the probability distribution. You can see here, let me just clear it off. This is more accurate. For phi, it was 0.75, whereas for 50, it's 0.2. Yeah, 0.045 was for 100, and 0.005 is for 1000. Here you can see they have told the bars are separated because they are discrete, they're whole numbers, right? Whereas if they're continuous, it would be a normal distribution graph. We will see that later. Another problem, here they have told an athletic director made a probability distribution of the heights of her team's basketball player and distributed a flyer that claimed that the majority of the players on the basketball team are 71 inches or taller. Is that true? Identify any flaws. Now look here, this is the probabilities, right? 71 to 75, you can see there is so much high, isn't it? And even over here 76 and 80. But in fact, if you see the next one, 66 to 61 to 65, 66 to 70, what are that probabilities? It's around more than 0.24. It can be 0.243 or something. What does this mean? 24.3% are 61.6, 61 to 65. 24 points so much are this range. About 26%, if you take it to the other side, 26% are 71 to 75. 26% are 76 to 80. So is this true? Majority, is that true? No, it's just 52% are about more than 70, 71 inches, whereas 48% are not. Now what did they do? They manipulated the data. They manipulated the data of the x-axis. See over here, they just shrunk this, they made these changes and made sure it looks like, okay, the 71 and 75 are much more higher, but in fact they have just manipulated the data along the y-axis and they have just reiterated. But if you write over here, 52% are only above 71%, whereas 48% are less than that. So it's not actually true. The scale of y-axis is misleading, because it shows the difference of probability. This looks more, but in fact they aren't. So that is the thing. And what about the sixth one? Here, the preliminary times for a 100-meter hurdles race are shown. This is shown here. Create a histogram of a set of data, determine whether the data can be approximated with a normal distribution. Now, here you can see this is not discrete because there are decimal points, but normal distribution, let's see whether it can be or no. That's a very bad line. Let's draw a straight line and see what is the minimum value. Minimum value over here, 75, 31, 35, 25. 25 is minimum. So let's start with 14. And what is the maximum value? I got some 84, 93. So let's end it up at 15. So you can split it out evenly however you desire. I would write 14.1, 0.2, 0.3. Okay, that's not proper. But anyways, you get the gist of it, right? So now you see, okay, this would be 14.1 because here, I have done very oddly. Anyways, this is 5, 6, 7, 8, 9, and so 10. Okay, so here you can see there is how many 25? There's 125 somewhere over here. You have one bar. What next? Let me just write 1 point. This over here, x-axis, okay? About how many people? Oh, y-axis. This is the x-axis given. Now, what next? How many are there in the next range? I can see after this it's 35. There is again one more person at 35. Next is 40s. Where is 40s? There is no one. Oh no, there is 2 in 30. 31, 35, and none in 40. So then we will go to 50s. There is none in 50s, but there are few in 60s, right? Here there is 60s and 60s. Then 70s, there is a couple of them. Now see, they are in fact overlapping in the same range. You can write some over here like this. 80s, there are few. Now this is not accurate. I'll just show you the accurate graph and I'll show you here. See this. 1. There were how many ones? Let me just go back here. You can see these were all ones. Then there were few ones and then some twos and threes, and then I've not done all. Here you can see this is approximately 14.25. Then next range would be 14.25 to 35. And then see over here 14, there is 3, 1, that is 1. From 3, 5 to 4, another range. And then here we can see there is no points until we come to 6. 6 to 6, 3, there is 1 point. Then 6, 5 to 7, 0 is another point. 7 to 7, 4, you can say another point. And then 7, 5, 7, 7 can be plotted together. Whereas all the others over here, there are 3, 1, 2, 3 in the same range. The range approximately of these is 0.05, in the sense 14.70 to 14.75, and then, or you can take it as 74, then 14.75 to 14.879, and so on. That's the range. Okay, so this is how we can easily plot this up. There's nothing much. Now this you can see is skewed. This is negatively skewed because it's down, it goes up, and it cannot be approximated with normal distribution. There's no much data over here, so that's the thing, and it's not properly aligned. And normal distribution, now they have told about normal distribution, has a mean of 186.4 and a standard deviation of 48.9. What range of values represent the middle? 99.7. You need to know the normal distribution curve. Let's just look at it. This is the normal distribution curve. Here, the middle one is given, this symbol is mu, mu, okay, but it's pronounced as mu. It's a Greek alphabet. Even this one, it's a small letter sigma. You have seen this sigma notation before, right? This is like capital, imagine A, capital A, small letter A is like this. This is the small letter of sigma. So this is sigma mu. Now here the mean is given by mu. This is the center. Whatever is the mean, what is it? Given as 186.4, right? That is this point here, 186.4. And the standard deviation, each of this, see this lines, dotted lines, at the middle it's always 50%, 50%. Now if you add one more line, because there are majority of the values here, 34% is added to it. So 50 plus 34, it's 84% data till here. That each additional line is given by the addition of sigma. That's over here. Sigma is given as 48.9. Now you need to know the middle part. C over here is given is 68%. Then if you add one sigma, it is 68% on both the sides. Let's add and subtract. Now if you add and subtract 2 sigmas to mu's, then it is 95%. If you add and subtract by 3 sigmas, it's 99.7. That is what we want. So now here it's very, very simple. You can memorize this value. 99.7 is given as sigma minus 3 pi. So the interval would be sigma minus 3, not pi, sorry, mu minus 3 sigma and mu plus 3 sigma. This is it. Now substitute the values. It's 186.4 minus 3 times 48.9. And here you have again 186.4 plus 3 times 48.9. Just find these values. That will be the answer. That will be the range of data that will represent 99.7. The 99.7 of the percent of the data. So here you can see it's 186. That's the mu minus 3 times 48.9. You get this, and here. So in this particular graph, for these particular values, this point, where is it? Sorry, 3. That's this over here, somewhere over here. Okay. See, it's not entirely 100%, but here it's 39.7 for this particular value, and over here it is 333.1. That's it. And the x value, see now this, any point over here we consider it to be x, because then we will solve the x value later on. X is given as whatever is z value, we require this for z value. We will see that later. Now it is within this range from 39.7 to 333.1, right? So x is less than this value, higher value, but greater than this. So we just write it like that. That's the answer. Now, what about this one? Again, let's see the normal distribution curve. They want to know what percent of data will be greater than 235.3. Where is 235.3? Let's try adding. Generally, it's always when you add once or twice, you will get it. If you add 186.4 plus 48.9, let's see, it'll be 40, consider this as 50, 30, 30, yeah, 36, yes, it'll be 235.3. I didn't do it approximately, but I know it'll be around 235, but obviously it's around that. So this is how much? Sigma plus standard deviation. Just once. Where is sigma plus standard deviation? It's more than, plus means it's the right side of 50%. This is 50% data, right? It's more than that. That's over here. So here it is 34%. This much is 50. So what percent data will be greater than, what percent? It'll be 84%. Why? Because you just add 50 and 34. Now here one important thing, I just realized it's greater than 235. So we need to find greater. What is this value? So how we find that is always, see, middle is 50%, right? 50% is known. How much is this point? From left side it is plus 34, that is 84%. Yes. But we need to know how much is remaining from more than that particular value, isn't it? So 100 minus 84% would mean 16%. So greater than this value would be 16% remaining data. So any value which is more than 235.3 or greater than 235.3 will be within the range of 16% only. So that is the answer. It's 16%. You do so much, 50 plus 34, it's 84, minus from 100, so you get the remaining data. You know, this much is 84, the remaining will be 16. The question number C is, what range of values represents the upper 2.5% of the data? Let's look into the normal distribution curve here. You know, this is 95% data, right? How much is remaining? There is 5% remaining, but 5% on both the sides. So each side will have 2.5%. Whenever they say upper 2.5, it's how much? Sigma plus 2 times, sorry, mu plus 2 times sigma. It's 186.4 plus 2 times 48.9. That would be the answer. Just put it in the calculator, you get the answer. So anything values more than 284.2% is the answer. Sorry, this is the mean value, right? When you add it, the data of 284.2 or more, that is representing the upper 2.5%. Now we have z-value problems. Here, these are very easy and simple problems. All you need to remember is one formula. Z-value is always given as x value. That will be either given or you need to solve it, minus mu, divided by what is remaining here? Sigma. Just these are the three things to remember. Now, z value can be positive or negative. If it's negative, it's in the left side of this normal distribution curve from its center, left. Positive is right. Now, let's solve this up. Here, since I've written the formula, I'll directly solve. Z value will be equal to 55.4 minus 68.34 divided by 9.8. That's the answer. Here, z value will be equal to 42.8 minus 68.2 divided by 11.6. That's it. You just put these in the calculator and you get the answers. You can see over here, you don't need to do so much substitution. Directly after substitution, after the formula, substitute, answer, only 3 steps. Even over here, the same substitution, directly answer. Now here both are negative values. That means it's in the left side of the normal distribution curve. Let me just show you here. That means minus 2 somewhere over here, you know. So many times sigma. Now 1 sigma 2, it's over here. So that's the thing. If it is 1.32, it is, you know, more than 1 but less than this somewhere over here. That's sigma value. So that's how we get the understanding of where exactly it lies in the normal curve. Even over here, it's the same formula. Now, you have been given z value of x value of 119.2 minus 112.4 divided by 11.9. Just put that in the calculator, you get the answer. This is positive because over here above it's positive, 0.57. Now here we have to use the table to find the area under the normal curve for each interval. See, these problems, you need to have a table. See, this table must be given to you. It's like a book or a page or a sheet, you know. If this is not given, it's not possible to find. I'm not sure how this question will be asked in your exam, because if they give you this, it's practically that's the answer. It's so easy. See over here, z value is greater than 0.58 from this table, which must be given to you. Otherwise, you cannot. The table must be given, you know. You don't memorize these values, they will be given. Now it's z value is 0. That's at the center. It's 50%. Now, if they ask you anything of z value at the center, 0.5, sorry, it's 0, 0.0. It's always 50% of the data. 0.5 is the answer. But here, they will ask you something else. If it's 0.58, then you have to look in this table, go down 0.5 and 0.58 will be going to the right towards the 8. This and this value will give you 0.58. What is the answer? 0.719. Now you need to find anything that's greater than 0.58, right? So greater than would be here, z value is 0.58. Z value is greater than. So you just have to know what is this point. What is that point exactly? From the table you get it as 0.7190. But you want to know greater. So total is 100. 100 means 1, 100% is 1 minus 0.719 gives you the answer. It's 0.281. That's it. If it was less than, then you just stop at this particular point. It's just 0.719. But you want to know the values greater than, right? Z values are greater. What interval? 100% minus this value. Even over here, you need to know this table. It's at the left, so it's C minus 1.5 and 6 is there. So it's minus 1.5006. That will be this value. So now you know this is the value. See, minus 0.156 is less than minus 2 over here. This particular distribution over here is 0.059. So then what do we need? It's just less than. So that is it. That is the answer. Because here, whatever you get is from the left side. From the left side here, it is how much? 0.0594. That's already known. That much percentage. If it was greater, you have to do 1 minus the remaining value. But here it's left side value. That is already given over here as the answer. So another value, there are 2 points. So you need to find the z value for both these points. Basically, you see the table and find it. And if these values are given, that's it. That will be the answer. And then here, see, let's look into the graph. I'll show you. We got these two values, right? One was, okay, now since it's in between, you're dealing with what's in between. You can just write these two answers for z value of minus 2.29, this much to this much. Now, how would you exactly get this answer? That's very simple. Look over here. This is the curve. I know this is 1 point. Imagine this is 1 and this is 2. Just for, example's sake. Now, what is the distance between these two? It will be 2 minus 1. Same way, I know that point over here for the greater point is 0.9971 minus 0.0110. If you do this, you will get the answer 0.9861. That is your answer. So the values, the table under this particular, the area under these two z values is so much. So you can see that will be the answer. Now you can see here the yellow part is representing that from here to here. And the last problem here we have, it's an open response question. A normal distribution has a mean of 347.2 and a standard deviation of 13. It's just like what we had done a while ago. Mean is given as mu, standard deviation by sigma. What percent of data is less than this? Now, how can you find this? The easiest way would be trying in your calculator. I'm sure it's not one time. It's not 1 time 13 minus this. You should try whether it's 2 times, 3 times, 4 times. Let's take our calculators here. All you do is write 347.2 minus, I'll try with 2 times 13.9. Is it 319.4? Yes, it's not one time because it's just a little less. It'll be about 30 something. So this is the answer. So now we know, if we see the normal distribution, we can understand it. Because it was less than mean, I know it's left side. Sorry, let's go here. Because it's minus, less than the mean, it's minus here. So how much is the value? What percent of data is less than, means left side? What is this? From year to year, this much is 95. See, this, or do from the middle. 50 year, this much is 84 plus 13.5. It'll be 97.5, right? What is remaining here? What data is remaining? It is 2.5 that is remaining. Or else you can also see year to year, it is 5%, 95. So 5% is remaining. So half of 5 and half of 5. Half of 5 is 2.5%. So the first answer will be 2.5% only. That much percent of data is remaining below this particular value. Now, what percent is greater than 361.1? Again, let's take our calculators. Here now I'll start adding because it's more than this, right? I'll start adding. If it's 2, it's way more. No. So I need to subtract by once, add by only 1 times the standard deviation. And here you can see it's 361.1. So that means, sorry for that, it's this point over here, 1. How much is from year to year? Half is 50. And here add this, it's 84%. Now we need greater than. They have clearly mentioned it's greater, not this answer. Greater, not 84. 100 minus 84% will be 16%. So that is your answer. So all the values that is greater than 361.1 is 16%. So there you go. So these would be the answers. And that's how you solve the question number 4. I hope this has been helpful. If you have any doubts, please post them in the comments. And I'll try to get back to you very soon. The question 5 is about trigonometry, unit circle, and periodic functions. Here, the first question is about constructing arguments. Here, we have to determine whether each statement is always true, sometimes, or never true. And we need to justify our argument. If k is a real number, then there is a value theta such that cos theta is equal to k. Now, here, what they are saying is cos theta. You know what is cos theta, right? If we graph it up, it starts from 1 and it keeps on going over here, and it starts repeating after 2 pi. This is 0, this is about pi, and it again repeats. Its period is 2 pi. But this is the theta value. We are not interested in this pi, x or theta, no. We have been told k is a real number. What is this k? It is basically like y is equal to cos theta. It's the range. What is the maximum range? 1 and minus 1. If you know the range of cos theta, or say for example sin theta, the range is minus 1 to 1. Both are included. So if you add any value, if you want the answer to be anything other than this, it's not possible for cos theta. Okay, unless you have 2 pi or something, the amplitude, or it's varied, then it goes, the range changes. But over here, no, it doesn't happen. So real numbers are numbers which are literally all numbers, rational and irrational numbers. You can consider it from minus infinity to infinity. All numbers are considered as real numbers. So here k cannot be that, because cosine is restricted from minus 1 to 1. It holds good till over here, it's big brackets. It is not always true. It's not never true, because it is correct over here in this case, but not any value less than minus 1 or greater than minus 1. So this is the first answer. It's sometimes true only. Cosine theta equals k, where k is real number, yes, from minus 1 to 1. It can be anything, 0.5, 0.7, anything like that, but not otherwise. Now sine theta is equal to sine theta plus 2 pi. What is sine theta graph? It starts from 0 and it keeps on going. It's 0, pi, this is 2 pi, and it starts repeating. Now if I continue it further, if I go over here, the 4 pi, see 0, 2 pi, 4 pi, all are same. Now what is this pi? If I add 2 pi to it, I'll be over here at 3 pi, isn't it? These both are same values. What is the y values? It's 0. Let's consider this over here. This and this over here, I have a difference of 2 pi. Why? Because the period of sine function is 2 pi. So whenever you see theta plus 2 pi for sine or cosine, it will be same as sine theta. This is true. It's always true. Why? Because you're adding the period, so it basically repeats every 2 pi. It repeats. See, this point is repeating after 2 pi. All points, even over here, if you see, for example, if you're considering, that'll repeat at 2 pi. So if you add sine theta by 2 pi, it will repeat itself. That's true. See, this was only sometimes true and this is always true. Now let's look into this one. N pi, theta is n pi, where n is a whole number, then cosine theta is equal to 1. Okay, let's write it out. Whole numbers means numbers that are positive. It's like whole numbers, not fractions or anything. It's 0, 1, 2, 3, 4, and so on. Theta is n pi. So what is n? This is n, right? So let's substitute over here. It's either 0 pi, then we have 1 pi, 2 pi, and so on. So now in such cases, let's understand, is it always equal to 1? I don't think so. Because over here we have 3 pi, 4 pi. If you know the graph of cosine, it's very easy. Or you can even check this in calculator. I'll show in a minute. Now it's something like this. Okay, that graph is not so accurate, but you get the gist of it. So this is 0. This is 2 pi here, and it would be again repeating at 4 pi and so on. But what about pi? This is pi. It's minus 1. It is true at all even whole numbers. See, at 2, 4, 0. Yes, it's 1, 1, 1. But what about 1? It's at minus pi. Minus 1, sorry. 3 pi is minus 1. So it doesn't hold good everywhere. It's sometimes true. Where n is a whole number, like 0, 1, 2, 3. At even numbers, including 0, it is true, but not otherwise. Now I'll show it in calculator. Now here it is cosine. Instead of theta, it's given as n pi. So n is 0 and pi, I will write it in degrees rather than converting to radian. Pi is 180 degrees. So this is basically 0 itself. Cos 0 is 1. Okay. But when I change it to 1, it's showing me negative 1. Whereas if I go back to 2, it'll be positive 1. If I go to any other even number, let me take 8, it is positive 1. But let me take an odd number over here, 13, it's minus 1. So this is sometimes true, not always true. Let's see the D option, D question. If theta is an angle in standard position in which the terminal side lies in the quadrant 4, then sine theta is positive. Let's look into this. This is the unit circle. We have to draw the cast diagram. It starts with C, A, S, T. It's the first quadrant here, second, third quadrant, fourth quadrant. What is the importance of this? Over here, all the trigonometric functions, sine, cosine, and tan are positive. Over here, it's only sine that is positive. Here, tan is only positive, and over here, only cosine is positive. It starts with 0. Over here, there's 90, there is 180 degrees, and then we have 270 degrees, isn't it? So now, if you have any other degree, say you have 30 degrees, over here, something like this, then we can easily find the point and everything. But now let's just stick to this particular question. They have told the angle is in standard position. Okay, it starts from here and the ending lies over here somewhere in the fourth quadrant. Imagine that's the point. Then sine is positive. Is it the case? When you reach over here, the fourth quadrant, look over here, the fourth quadrant, which is positive, cosine only. If it was first or second quadrant, yes, this is always true. Not over here. Third and fourth, it's wrong. Sine is not positive, it's negative, and this is always never true. The C was sometimes true. Yes, that's the answer. And over here, it's never true because it's never positive in the fourth quadrant. Sine is not positive. Sorry. Now here we have a problem where point P lies in the unit circle. Let me get the unit circle back. It's important again over here. And on the line y equals x, what is line y equals x? This is a straight line of 45 degree. The slope is 1 and it's a positive slope and it's going upwards. Now where can you draw this? Over here it's like this. It'll be 45 degree, and you can extend it backwards as well. Okay, if theta is an angle in standard position in which the terminal side contains P, wherever it's ending terminal, it's containing P, what can you conclude about sine theta and cosine theta? So now you must remember y is equal to x, right? This is 45-degree line. If you know 45 degree is, and this one will be 225 degrees. So there is an important relationship. Wherever it's 45, it's exactly in the middle. Sine theta over here will be equal to cosine theta for all this. And if it's in the first quadrant, what happens? They both are positive. Sine and cosine are positive and positive. Whereas over here, sine and cosine are negative and negative. Few of the things you can conclude about this. In first quadrant, sine theta and cosine theta are positive and they both are equal, positive values. In the third quadrant, they both are negative, but still they're equal. So that is what you can conclude. Let's see what's written over here. See, they have told, yes, the same things. It can be either in the quadrant 1 or 3 because this line extends to first quadrant or the third quadrant. And in the first quadrant, they both are positive values, and whereas in third, they're negative. And you can always tell sine is equal to cosine because, at 45 degree, they both are equal. Let me show in calculator as well. Here, let me take sine 45 degrees. That'll be root 2 by 2, I believe. Yes. And change this to cosine. It'll be the same thing. But whereas if I change it to 225 degrees, only thing is it's negative. And then let me change it to sine. That's the same value but negative value. So they both are equal at this line. Y is equal to x means it's 45 degrees. Now we have a real world problem using the model. The wheel at a water park has a radius r is how much? 1 meter. As the water flows, the wheel turns counterclockwise. That's left side, opposite direction of the clock. As shown over here, a point P, so this is the point P, on the edge of the wheel begins at the surface of the water. Now see here, it's on the surface of the water, it keeps on moving. And the function that it moves is given as f of x is equal to sine x. Represent the height of P, sorry, this is the function f of x. It represents the height of P above or below the surface of the water as the wheel rotates through an angle of x degrees. So now, as x varies, you come to know where is the point P. It's either up or down. That's this particular function tells you the height of the P point, wherever it is. So that is the initial conditions given to us. Now there are many sub questions. The first one A is, how far does the point P travel as the wheel rotates through an angle of 3 pi by 4? Okay, now this is given in radians. Now basically what they want is, what is the length of this from here? How much is it traveling if there is an angle of, say, imagine this is the angle theta is 3 pi by 4. How much is this length? That is found by arc length, right? Arc length is given by L equals r theta. But here the condition is theta cannot be in degrees, it has to be in radians. So all you need to do over here basically, L is equal to, what is the radius? It's 1 times, what is theta? It's 3 pi by 4. So length will be 3 pi by 4 itself because the radius is 1. If it was different radius, then it changes. You need to solve it up and write it over here. It's in meters, length, meters. So that's it. So over here, because radius is in meters, that's why I'm using length as meters itself. So that would be the arc length, 3 pi by 4 meters. See, now they have just written directly, but it's better you write the formula and solve it up. That would that makes, that shows that you understood the problem properly. Now here we need to graph sine x. Okay. Now, if you know the sine function, you can directly start from 0 because it's just x. See, look over here. There is nothing attached to it. There is no pi by 2 or anything towards x. It's only x degrees. So it would be very easy for you to graph. It will be something like that. This will be 0. This is 2 pi over here. This is pi. This is pi by 2. That is 45. I mean 90 degrees, 3 pi by 2, and so on. But now, how exactly will you graph if you don't know this already? You can use your calculator. I'll show you now. You can use mode and 7 and graph literally any equation. And since it's sine x, let me consider this as x. I will not change my mode to radian. It's in degrees only. Let me leave it like that. But before that, we need the table of values, right? Over here, this table is very important. X and y, isn't it? So now here, remember, whenever your sine function start always with 0. You can try 30 degrees or 45 degrees or something like that. I'll take 45, 90. Okay, every 45, just keep on adding 45. It'll be 135, 180. You can also go with 0, 90, 180, and so on. It's up to you. It'll be 225 here. Then we have 270. And then we have, it goes until 360. Okay, 315, and so on. That much only. I've just taken one period. So these are the values. Now, how would you type it in the calculator? After typing the sine x, ignore this. If you have the latest model of the calculator, you get this option. You just click on equal to. But many of you may directly be directed to start over here. Start for all the trigonometric functions at 0. Start at 0. Now, end at where do I want to end? At least one period is good. You can go to more periods as well. If you can take 720 and all, but I'll just stick with one period. That's 360. Now, what is the step? Don't put 1. If you press equal to here, it will tell insufficient memory because there will be 360 columns which cannot be produced in your calculator. So now here, start at 0, end at 360. Give the step of 45. That means every 45 values, the values after multiples of 45 will be registered here. So if I write 45, make it equal, so I can see 0, 45, 90, and so on. So you need to write these values here. See this one. At 0, it's 0. At 45, it's 0.707. It's basically root 2 by 2. And at 90, it's 1. Again, it's a root 2 by 2. And then over here, we will have at 180, again, it's 0. Then again, root 2 by 2, 1, and so on. Okay. So these are the values. And then now you would plot the points. See over here, this graph. Over here, the values are also given. Here we will use this table of values and I will tell you how you plot it. X is 0, this is 0, and y is also 0. Whereas when x is pi by 2, what is the y value? It's 1. Okay, this pi by 2 is 90 degrees. So we had taken more values. When I did in the calculator, I took 0, 45, and so on. They have taken a step of 90 only, 90, 180, 270, and so on. So this is also fine. But I'll tell you, sometimes when there are some values over here, you need to take the x values accordingly. So that I'll tell you when we come across such problems. Now here, see, you can see this is 90 is 1. Pi is basically 180 degree. That's over here. It's 0, and so on. You can even write over here in degrees if you want. You can write this as 180, this as 360. It's up to you. That is absolutely fine. So I hope this is clear. So that's how we graph this. And you can see the maximum point is 1. The minimum point is -1. Now then we will go to the next one. What is the period of the function? Explain how you know. Explain how the period is shown in the graph. What does the period tell you about the point P? Let's go back to the graph over here. What is the period? Period is when the graph repeats itself. Now if you see over here the starting point 0, it starts over here and repeats over here. And then, let me just change the color here. This again is a repetition from 0 to pi. Can you see the same thing? Then again it will repeat and it keeps on going. So every 2 pi it repeats. So that is basically the period, you know. Whenever the graph starts to repeat itself, that will be the period. How do you know? You can just observe the graph from 0 to 2 pi. It's all unique values. See, it goes up, down. But now the movement is repeated, so that's why it's the period. So here you can see there is another way of answer. But as long as you understood it's repeating, that's the period. That's it. That's the main purpose of period. To understand from where onwards the graph repeats itself. Now, what about D? What are the x-intercepts? We need to look at the graph again over here. What are the x-intercepts? Wherever the graph touches the x-axis, it's at 0, pi, 2 pi, 3 pi, and so on. All the multiples of pi, basically. See the whole number multiples. It's not it has to be whole numbers like 1, 0, 1, 2, 3, 4, 5, 6. When you multiply to pi, you will see it always touches the x-axis. That is basically the intercepts. Now, okay, over here we need to also tell what does it represents to this situation, right? Now that is basically all the points where this point is touching the surface. It's coming to the surface because the surface over here is the x-axis. So that is the thing. And even over here, what does the period indicate to this point P? Because we have been given a figure. So what it indicates is it completed one complete rotation. See, from this point P, let me just draw it over here. It moved like this and it came back to the original position. That is what it indicates. It keeps on repeating itself, right? That's one way you can answer. And over here we have to identify an interval where the function is decreasing. What does it represent? Now let's go back to the graph. See here, at pi by 2, that's 90 degrees, it's having a maximum point 1, but then it's decreasing, right? It's going down. What does it represent over here? Let's look into this particular point. Here it goes up, then it's going downwards and going downwards towards the water. Then again it's going upwards. So that is what it represents, going down and up. Yeah, they have chosen the same point, pi by 2, and then it moves downwards till it reaches its maximum height. Then it keeps on going up. It's basically repeating again. So that is basic understanding of this particular problem. Let's do another problem now. See, there's no figure, but they have told a point P on the edge of a car tire. Again, it's a circle, is marked with paint. As the car moves slowly, the marked point on the tire varies in distance from the surface of the road. Okay, the height of the point is given by this function, and where t is the time in seconds. So the height varies depending on the time. As the time is moving, it is moving like this, right? That's the tire. Now, what we need to do is, again, there are sub questions. What is the maximum height above the ground and the point on the tire that the point on the tire reaches? So now imagine there's a point over here. As the tire moves, okay, it'll go down, it'll go up, it keeps on moving, it reaches the maximum, lowest, midpoints, everywhere it reaches, right? How can you find that? It's very simple. We have been given this particular equation, we can just graph it off. Or we don't need to graph, sorry. We can just find the table of values. How would you do that? Is in your calculator. We will press mode and 7 to get the table. Now let's write this out. -8 cosine. Instead of t, we'll put alpha x. Close the bracket plus 8. Now, what are the starting points and ending points? We will start again always at 0. Let me end at 360. I just want one particular period, because since over here the degree is what? Only t. There is nothing pi or 2 pi, nothing is added. So it's fine. I can just take it as, end it at 360 degrees, or you can go to 720 as well. I will take the step of 45, same like the previous one. And these are the values. You can see the maximum value over here at the right side, f of x. What is the maximum value? I saw 16. Oh, that's it. 16 is the maximum one. And what about the minimum value? Minimum is 0 itself. Obviously, it'll reach the ground, right? So now what it means is if you have this tire over here, the height, the maximum height it can go, height is in inches, it's 16 inches. We got it. And the lowest is 0. And these, all the other points are different points over here, basically. Okay, that is what it means. So you can see, now here they have taken a period. The step is of 90 degrees. Okay, we have taken 45 degrees. That's fine. We'll get more points. That's it. Here also you can see it's maximum 16, lowest is 0. So it's 16 inches. And what is the minimum height above the ground that the point on the tire reaches? Minimum. Minimum is 0 basically. There's no height at all. We saw it just now, right? Here in this figure, that's 0. And how many rotations does the tire make per second? Okay, this is important. Now, here they have clearly told t is time in seconds. So whatever this is there, it's in seconds. Now, this is cosine. So let me just graph it. Imagine this is a cosine graph. Here, these are all the graphs, right? Now, we should know what is the period. Period is how much here. If we go back in our table also, we got it's 2 pi, 0 to 2 pi, and then it repeats itself. So here, the period, all these are unique values, and now again we will start repeating. So period of cosine function, whenever there is no other pi or anything, it's directly period is 2 pi. So now in this case, what happens is 2 pi is the time for one cycle or one rotation. So why is this 2 pi? Because this axis, x-axis, is in time per second. So now whatever is over here, the period is basically one rotation in so much time. In other words, I'll just write over here, one rotation takes 2 pi seconds. Okay, so this is the condition. One rotation takes 2 pi seconds. Now they don't want how much time it takes for one rotation. They want how many rotation does the tire make per second. So now I know the rotation and the time, right? For one rotation it takes 2 pi seconds. How much rotation does it take for 1 second? I want the time as 1 second. How would you solve this? So you just cross multiply this 1 multiplied by 1 divided by 2 pi is equal to x. So it's basically 1 by 2 pi. Or you can just see the time for one rotation is 2 pi. So inverse of that will be basically the answer. So it's 1 by 2 pi, is the number of rotations per second. This is the answer. And how far does the marked point travel in 30 seconds? Now, this is again another important thing. How far does the mark point travel in 1 hour? There are two questions here. First, let me do 30 seconds. Now, whatever we got just a while ago, in 1 second, how many rotations in 1 second is 1 by 2 pi, right? This is very important. And what else do we know? We know the point over here, the number of seconds is 30 seconds. But this is the circle, okay? So we need to know what is the total circumference. Why? Because they're asking how far does the mark point travel, right? This mark point, how far does it travel? That means one complete rotation is how much basically? It's circumference of the circle. It's 2 pi r. But now we do not have the 2 pi r radius, but from the values, you can, let's just go back for a second. Here, what is the maximum and minimum height? Maximum is 16, minimum is 0, right? So what you can see over here is, let me just write it out over here. From here to here, it's 0 to 16. So what is the diameter over here? Diameter is basically 16. So now that is, instead of radius, we have the diameter, or the radius r is 8, half of it, right? So half would be 8. Now you can either use the circumference formula as 2 pi r, or you can use the circumference of pi d. It's up to you. If you use over here r, it will be 8 times 2, it will be 16. Here you can directly use 16. Anyways, the answer would be pi times 16 or 16 pi. So this is the diameter, the circumference. So now if I know the circumference, and then I know how much rotations per second, right? So what I'll do is, I'll multiply the circumference 16 pi multiplied by this one over here, gives me per second the distance traveled, whatever is the distance traveled per second I'm getting, because this is the total rotations per second, right? So circumference multiplied the rotations per second will give me for 1 second. This much is basically for 1 second. But how much distance do we want? How much does the point travel in 30 seconds? So multiply this by 30, you get the answer for the first one. Let's just solve this up to 1 times 8 pi times 8 3s are 24 and 0. It is 240 inches. That is the distance traveled. And the same thing they ask for 1 hour. Now, what do we do over here? So again, we know this one. We can just rearrange this basically. We can, or you can just change this to 3600. It's up to you. Now, I'll change the same formula, just the seconds I will change it to 1 hour. What do I do is, see here, I'll write it again, and 16 pi is the circumference, and 1 by 2 pi is basically a number of rotations per second. So I got the total distance traveled in 1 second. This much is for 1 second. Now I need 1 hour. How much is 1 hour basically? In seconds I need. 60 times 60 is 3600. So 3600 seconds is 1 hour. You know, you can just multiply 60 seconds into 60 minutes. That many seconds are the 1 hour. Are there in 1 hour? So I multiply this by 3600. So pi cancels again now. Here it's 16 and 8. So 8 times 3600, that much inches is the distance traveled. Now you can just use your calculator over here. But I'll just try doing over here. 360 minus 72. It's 290 to 88, and there are two zeros. So it must be this as the answer. So many inches. Let's just use our calculators and solve. Directly you can put it and you'll get the answer. Now when you're solving, you can put this calculator pi as well, but since pi cancels off, what you can just do is directly put the numbers only. 16 multiplied by 30 divided by 2. That will be the number of, okay, this is, sorry, 30. I need to multiply it by 30. Now that is 240 inches. That is for 30 seconds. Now all you do is just change this to 3600 and you get it over here. So these are the two answers. Okay, now whatever answer we got is in terms of inches, but if you want in feet, which they have not asked, you can just divide by 12, because 1 feet is 12 inches. You just divide by 12 and you get in terms of feet as well. This is up to you. So this is how we solve this particular problem. The next question is about temperatures. The temperature T in degrees Fahrenheit of a city T months into the year is approximated by this formula given over here. What is the highest monthly temperature for the city? Now again, they have asked you highest or lowest. It's directly by the table of values. You have to make a table. But before that, here you can see there is pi by 6. So the period wouldn't be just 2 pi anymore. It's not 2 pi. This changes. How does it changes? I will convert this to degrees because it's much easier for me to analyze in degrees. That's why I do in degrees. 180 by 6, that is 30 degrees over here. So it's 30 degrees. What you need to do is, what was the original period of sine? It's 360, right? Divide this by whatever this over here is there, the coefficient, that's the b value. It's 30 degrees. Now solve it up. It'll be 12. So 12 is the new period. So now in order to get one complete cycle, you need to write from 0 to 12. Let's do it in the calculator now. And there's one more thing over here. Since it's already told months of years are 12. So it must be 12, you know. Here let's go to mode and 7 and then type in this equation, 42 plus 30 sine. Now here, if I'm going to write pi by 6, I'm going to get an error because I'm converting everything in degrees, isn't it? So if I have the mode in degrees, I have to write in degrees. Now pi by 6 is 30 degrees. You can just remember pi is 180. Always divide 180 by 6. You'll get in degrees. Then multiply it with alpha x. Close the bracket. Start it at 0. Ending is at 12. Remember, now since we have already considered the period, what is this t value? It must be 1 only. Step must be 1 itself. And now we are getting the values at 0, the first month, 42. Sorry, 0 is the first month is 57, second, third, fourth, and so on. So don't think 0 is the first month. No, first month will be 1, and over here it's 57. That is January, February, March, and so on. What is the maximum value? I think so 72 is the maximum. So maximum temperature is 72 degrees. See, that's the same one over here. You need to do for all the months. And then in what month does the highest temperature occur? See, they have already found out the maximum is 72 degrees. In which month? The month 3, that is March. Here it's March. And what's the lowest temperature? Let's go back to the table over here. Lowest temperature you can just check is 16, I believe. There's no other 16. So it's 16 at 8 and at 10. Is there any other lower? No. It's 16. Oh no, there's 12. Where is 12? Okay, over here in between was 16. I'm so sorry. It is 12. So just be careful in looking at the values. It was just not visible for me somehow. So that is 12 degrees. And which month, if they ask you, it'll be month 9, that is September. And in what month does the lowest temperature occur? It's the ninth month, that is in September. And that's it. It was a very simple question altogether. Now, the last question in this topic. A machine in a factory has a gear with a radius of 1 foot. So the radius over here is basically 1 foot. Any a point P, there's a point P over there. On the edge of the gear begins at the furthest point from the wall. You can see, if I just remove this over here, you can see this is the furthest point. This is the wall, and this is the farthest point, the furthest point. And then the gear begins to rotate clockwise over here, not counterclockwise, sorry. It's counterclockwise, that means going towards the left direction. The function cos x plus 2 represents the distance from distance of P from the wall as the gear rotates through an angle of x radians. So now what they are saying is this is a gear, right? It's rotating from here. It keeps on rotating like this. And this function over here basically tells you the distance. Now at 0, let's consider at 0, when x is 0 radians, what happens? This is 1 plus 2, that is 3. So it is 3 feet away from the wall when it is at 0, when it is at that position. Okay, the radius is 1 feet, this is also 1 feet, and there is one more extra feet which is away basically. Now imagine we change this cos x to say 90 degrees. Let me make it 90 degrees. Cos 90 is 0, so it'll be 0 plus 2, that is 2. So if it is at 90 degree P over here, 1 feet is gone. How much is remaining? It's just 2 feet. Over here it was 3 feet, the total maximum distance. I'm just telling you, as it moves over here, how much will it be? It'll be just 1 feet, because it'll be minus 1, right? So 2 minus 1 will be 1 feet remaining. So that is the situation over here. Now what does this particular function represent? Now we have the function f of x is equal to cosine x plus 2. Instead of x, what do we have? We have pi by 2. So we just put cosine pi by 2 plus 2. Now it's up to you. You can change this to degree. Pi by 2 is 90 degrees. You can leave it as pi by 2, change the mode to radian and solve, but I would just change it to degrees. And over here it's 90 degrees plus 2. The reason I changed to degrees is it's much easier for me to understand in degrees. Okay, this is 90 degree, this much is 180 degree, and so on, it easily comes to my mind. Radian, I will have to think a bit, okay, it's 2 pi, 3 pi, or it's 3/4 pi radians. I take my time in radians, so I just convert to degrees, so it'll be easy for me. It's up to you to choose. And now cosine 90 degrees. What happens at 90 degrees? Cosine 90 is basically 0. You can do it in the calculator. Plus 2. So answer is 2. So the first one, f of pi by 2 is basically 2. That means the point P is 2 feet away from the wall. That is what it says. See, it's 2 feet from the wall. And the next question is we need to graph the coordinate plane. Now how do we graph? It's very simple from the calculator. Again, mode 7, and now let's type it out. Cosine x, that is alpha x. So now what did I type? It's cosine x alpha x. Close the bracket, plus 2. And now start it at 0. I'll end it at 0 degrees 360, because there's nothing. The period is 360. And I will give a step of 45 degrees. So you can see at every angle what is the distance. The least distance it will go is at 180 degrees, it will be 1, and the maximum distance it will be in its original position of 3. So you just get these and you can graph, it will be something like this. Okay. Now you can see at 0 it is 3, this is 5, 4, 3. And the lowest it will go is 2 at pi. Pi is 180 degrees, and so on. That's from this values. Say 4 pi is also 3. And what is the period of the function? Now period of the function is basically 2 pi. See in this graph we have, right? It's how much? 2 pi. After this again it repeats, keeps on repeating. So the period is 2 pi. And what does it tell you about p? That's the distance from the wall, So it keeps on changing. The distance keeps on changing, and once it finishes 1p, then it repeats itself. That is what it says. What is the maximum and minimum values of the function? We in the graph. Maximum is 3, minimum is 1. So that's it. So maximum is 3 feet away from the wall, whereas minimum it is the closest point. It's 1 feet away from the wall. That is the end of all the writing part questions. If you have found these videos helpful, please share it with your friends. Let them know about this channel Best Math, where you can find all the end of term exam questions and exam lessons explanation for free. And I just want to thank all the students who like my videos, who share my videos, and all the gratitude comments. I really thank you so much. Your comments really make my day. A single thank you always puts a big smile on my face. Thank you very much. And I wish you all the best in your exams. I hope everyone does well. If you have any doubts, any clarifications, please do post them in the comments and I will get back to you.